Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 30th, 2025, about 4 days ago. This paper shows that applying the learned adaptive computation time halting policy at inference dramatically boosts reasoning, raising Sudoku-Extreme exact accuracy from the originally reported about 55% to above 90%, while often stopping in just 2 to 4 steps. The paper is titled Hierarchical Reasoning Model, a critical supplementary material, and the implications for model training are quite significant. It reframes the approach as latent consistency or diffusion-style learning, finds an 8-layer low-level only variant competitive, and roughly doubles Maze-Hard performance within 30,000 iterations. Alright, the introduction underscored how adaptive computation time at inference lifted accuracy while saving steps. The figure compares the original hierarchical model to an 8-layer low-level only variant that applies adaptive computation time during evaluation. The left panel shows exact accuracy rising, with the 8-layer variant climbing above 80%, while the original plateaus near 50%. The right panel reports average reasoning steps, which drop to roughly 4 by 20,000 steps and remain far below the fixed 16-step baseline. So the previous figure showed headline gains from using adaptive computation time during evaluation. This figure contrasts accuracy and efficiency over training steps. Panel A charts exact accuracy, where the adaptive computation time variant climbs from near 0 to roughly 90%, while the original model plateaus around 50%. Panel B reports average reasoning steps, which fall from about 15 to near 2, staying far below the fixed 16-step baseline because the halting policy learns when to stop. So the previous figure highlighted rising accuracy with fewer steps. Figure 3 shows Sudoku trajectories across reasoning steps, from the input puzzle to the target solution, with adaptive computation time deciding when to halt. The grids converge rapidly, which means most cells settle within 2 to 4 updates. Several examples stop at step 4 or 6, indicating that the halting policy detects efficiency early. The visualization underscores that latent refinements accumulate fast, so exact solutions emerge in very few iterations. While Figure 4 compares accuracy and compute on Maze-Hard, so it extends the Sudoku story to a different task. Panel A shows exact accuracy, where the adaptive computation time model stays near 78% across training, while the original peaks near 43% and then dips toward the mid-30s. Panel B reports reasoning steps, which the halting policy cuts from roughly 5 to about 3, while the original remains fixed at 16. Wrapping up, 2 takeaways stand out. Using adaptive computation time at inference is decisive for both accuracy and efficiency, and latent consistency style training explains the few-step convergence while making the high and low split look optional. The broader implication is leaner reasoning systems that halt early, cut compute, and demand better evaluation protocols. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.